Hello, this is Gareth Keane. I'm continuing on here with the series of videos showing how to program in VBA for Excel. The program I'm going to look at today is how to implement a Maclaurin series to calculate the exponential of x using the Maclaurin series but using an indefinite loop. So we're going to use a do loop until structure in VBA. Last week in the previous program you did the same exercise but you used a definite loop using the for next structure. So I'll start off. You're going to have this form will be supplied to you. It'll be in your public directory. So I'll start to write the code. If you notice, you have a text box here for x, so the user puts in the value that they want to work out the exponential of. You can see I've called it text x. And this text box here I've called text tolerance, and as I explained on the video on the studio code, that's going to be used to determine when the solution has converged, when the Maclaurin series has converged to a satisfactory answer with enough accuracy. The accuracy is determined by this value here. If I click on the button, I'll call this button command indefinite loop, and I will start to write the code. First thing I do, as before, is I put in option explicit at the top, and that forces you to declare any variable that you use in the program. It's very useful to avoid making mistakes, which can be easy to make when you're declaring variables and using them in a program. So the first thing I do is dimension k as an integer, and I'll dimension x as a double, so that's the value the user puts in. Term is going to be used to store each new term of the Maclaurin series as it's calculated, and exponential x is used to store the result, the running total as the program runs through the loop. Dimension diff as a double, so that's going to be the difference between exponential x from one iteration to the next. Tolerance will be used to determine the accuracy of the result, which you'll see when we run through it. And temp is used to store the value of exponential x from the previous iteration before the new value is calculated, which in turn will wipe out the old value. If you remember, a variable can only store one value at a time. If we want to know the difference between exponential x from one iteration and the next, because the variable only stores one value, we have to store the previous value in the temporary variable, which we call temp. X is equal to val text x dot text. So the first thing it will read in is the value that the user puts in for that they want to work out the exponential of. Tolerance is equal to val text tolerance dot text. Now notice some of you make mistakes where you don't use the right name when you're actually looking at one of the controls on the form. You know it's correct when you type the name of the text. I know there's a text box out there called text tolerance. Just to check it, when I press the full stop here, we get all these. It comes up in an auto menu with all the commands and properties of a text box. So what I'm looking for is the text property, so I can just type in text and there it is. So I know it's correct once I hit the full stop. If that auto list comes up, I know that control exists out on the form. If it doesn't come up when you press, after you type the name of the control and press full stop, that means you've spelled it wrong, or it doesn't exist out on the form. Then we're going to initialize exponential x is equal to 1 for this particular series. K is equal to 0. So that says for the first term of the series, and you start with k equal to 0, exponential is equal to 1. Then I have do, and the structure we're going to use is do loop until, and it's like this, and we're going to say diff is less than tolerance. So I'm putting the last line in before we actually give those values, but that shows the structure of the loop. That as we go through the loop, we're going to calculate we're going to calculate each new term. We're going to add it on to exponential x, and we're going to work out the difference between the current and the previous value of exponential x. We're going to store that in diff, and if it's less than tolerance, we will basically exit the loop. So if I run through it line by line, k is equal to k plus 1. Temp, so every time you go through that loop, you have to increment the value of k. That means you add 1 to it. Temp is equal to exponential k, x. Term is equal to x to the power of k divided by the factorial. Okay, and we'll use the worksheet function for that. And it comes up automatically, fact k like so. What have I forgotten here? I just need to space that out to make it work properly. So term is equal to x. Remember, if you're using this power function exponentiation, it's above the 6. You have to put a space before and after to make it work properly. Okay, next thing is if we calculate the new term, we need to add it on to the exponential of x. So this will take the previous value of exponential x and it adds the term onto it. Then we need to work out the difference, the absolute difference. That means even if it's negative, it'll switch and make it positive. Exponential of x minus temp. So remember, temp stores the previous value of exponential x before we came in and calculated. On the next step, we calculate the term and add it on to exponential x. So now we have the difference between the two of them. I have to just do these steps here for formatting purposes. I did them last week in the previous example. We'll have an else and an end of structure, and this is just in terms of formatting the output correctly. So we say output string is equal to output string ampersand k ampersand VB tab ampersand format term scientific. So we did this last week. So you're going to give it scientific. I spelled it wrong there. Scientific. So we're going to print out the term in scientific notation. And now there's a trick here. This is going to be a very long statement, so if I want to continue on the next line, I put a space after that and I hold an underscore. So the shift button and the underscore, and it allows me to continue on to the next line. Sorry, I did something wrong there. Yep. And I continue on the next line, so I say space 5. Space 5. And format. So this is the same statement we actually used in the example last week. Ampersand 1, 2, 3, 4, 5, something like that, 6 or 7. Ampersand and space 5 and format diff. So I'm going to also output diff here with the same number of decimal places. I'll just copy and paste it over here. Control Z to copy, Control V to paste. And what I'll do is I'll do ampersand and underscore, so I can continue this on the next line, and I'll do VB new line to force it on to the next line. Doesn't like something I did there. I wonder what it is. Format term. So it doesn't like something that I did there. Format. That's what it was. I didn't have the space there, and it was causing trouble. You need to have the space after the VB tab. So I was wondering what was going on there, but it's just I didn't have a space in the correct place. Now, if I remember rightly, what I need to do here is I need to take this guy here, Control C to copy, Control V to paste. I'm sorry, it should be on the next line, like that. And the only difference I'll do here, I'm just tidying that up a bit, is that I have a space of 6 if the term is less than if it's greater than 1. It just has to do with the formatting to make the formatting look correct. So I have everything done there. The last thing I need is to output the answer onto the text box, which is called the large text box. Maclaurin series dot text is equal to output string, like so. Okay, so I'm going to run this F8. As you can see, there's default values for x and the tolerance in there, so I'll leave those there. I'll press this button here and I'll start to go through step by step. X is equal to val text text, tolerance is equal to val text tolerance text. If I do Control G, I open up this immediate window and I can print those two values, if I spell them right. So you can see tolerance is 0.000001. So that's the level of accuracy. You'll see it when we run through it. If I go exponential 1 is equal to exponential x is equal to 1, k is equal to 0, and now we're in the loop. So what I'll do here is I'll print out a couple of things here. I'll print k, I'll print term, I'll print temp, exponential x, and diff. Okay, so we'll print all of those statements. At the moment, the only one that has a value is exponential x. I'll just delete this guy out of the way, and delete them so we're starting fresh. So let's run through it. F8, so k is should be equal to 1, temp is equal to exponential x, so it should have the value 1. Now we calculate the new term, and then we add that term onto exponential x, and then I calculate the diff. So I calculated all 4 items. So k was 1, term is equal to 2, temp is 1, that's the previous value of exponential x. Exponential is now 3 because we added on the term, the new term for k equal to 1 onto the previous value of exponential x, which is 1, and the difference between them is 2. So if you come down here, that'll output it onto the string, and I'm looping here until the difference, which is 2, is less than the tolerance. And if you remember, we set the tolerance to 1e to the minus 7. So 2 is not less than 1e to the minus 7, so we're going to continue on to the next term. So k now should be equal to 2, because I stored a previous value of exponential x in temp. Calculate the term for k equal to 2. Calculate exponential x, I add that term onto the previous value of exponential x, and then I work out the difference between them. So let's print those out here in the immediate window. So for k equals 2, the term is equal to 2, the previous value of exponential x was 3, it's stored in temp, exponential x now is 5, and the difference between them is 2. So if I come down, 2 is not less than the tolerance, so it comes around and we're going to calculate the next one. K now should be equal to 3. So if I press this, I might just space these out a little bit if that works. So I'll put them over where they get printed out. And that should still work, hopefully. Yeah, you can see, well, now they have fractional parts, but K is equal to 3, the term now is 1.33. The previous value of exponential was x was 5, but now the 1.33 gets added onto it, so now it's 6.33, and our difference is now going down. It was 2 the last time, but now it's 1.33. I'll keep going for a few more. So that should be k equal to 4. I went through them very quickly. You can see our difference is reducing on the end. Exponential x is getting bigger, because now it's fractional parts that they're not aligned again. That's temp x. So you can see here now that the new term for k equal to 4 is 0.666. The previous value of exponential x was 6.33, but now when we add this on, we get 7. The difference between these two values, exponential x and temp, is the value of the term, so that is now reducing each time. If I could do it again, that's for k equal to 5. I ran through the 4 of them and calculated them. Come back in here. So for k equal to 5, the term is 0.266 and it gets added on to the previous value. But you can see each time the difference is dropping. So what I'm going to do is just press F5 to let it run to the end. And you can see here that with this level of accuracy where we say tolerance is 1e to the minus 7, it takes 15 terms until we get it accurate. The value of exponential x is 7.3890566095. You can still see a small difference between these two last values, and the difference is a very small number. But if we say we wanted more accuracy there, we can say 1e to the minus 10. Now if I press calculate here, you can see it takes 3 more steps. But you can see now the difference is very accurate. It's more accurate. There's no difference between these two values here at a value of 1e to the minus 10. Now the only thing about this is, say I increase this value to 5 and do it, because it's a bigger value, it actually takes 29 terms. The answer is 148.4131595 and so on. What we're saying is it takes 29 terms because the value of x is bigger until we get convergence. What if I go and do a bigger value? I think this is going to mess up the formatting, but no, it's fine. So you can see here, if I click into the box and scroll down, for exponential of 10, it takes 44 terms, or 43 terms, until we're getting convergence. Just do another one, 20. Hopefully this doesn't break it. Now you can see the formatting is wrong, but if I click in, you can see it's 68 terms for exponential 20 until we get accuracy. Okay, that's great. Thanks for listening.